This video provides an introduction to reduced row echelon form. So let's look at the other form of an augmented matrix that we can use to solve systems of equations called reduced row echelon form. Reduced row echelon form is frequently abbreviated RREF. Reduced row echelon form, like row echelon form, has four characteristics. The first three are the same as row echelon form. Any row consisting entirely of zeros are at the bottom of the matrix. For each row that does not consist entirely of zeros, the first leftmost non-zero entry is a positive 1 that we call a leading 1. For two successive non-zero rows, the leading 1 in the higher row is farther to the left than the leading 1 in the lower row. So those first three characteristics are the same. The only difference comes in our fourth characteristic. Characteristic number 4 says every column containing a leading 1 has zeros in every position both below and above the leading 1. Here are three matrices that demonstrate the characteristics of reduced row echelon form. This first one is our ideal case that will produce a solution of real numbers. Notice that there are 1s on the diagonal and zeros everywhere else to the left of our vertical line. The other two examples there are in reduced row echelon form, but they're not our ideal case. They're going to produce either no solution or an infinite number of solutions. So let's determine whether these next three matrices are in reduced row echelon form or not. And we'll just go through the four characteristics for each matrix. Looking at this first one, characteristic number 1 says that if there's a zero row, it's at the bottom. Well, it doesn't have a zero row. Characteristic number 2 says that the first non-zero entry coming in from the left is a positive 1. Satisfies that characteristic. Number 3 says that the leading 1 in the row above is farther to the left. Also true. And characteristic number 4 says that we have zeros above and below each of our leading 1s. Notice in the first row, second column, and in the second row, third column, we have numbers other than 0. Therefore, this is not in reduced row echelon form. Let's take a look at our next one. Characteristic 1 says if there is a zero row, it's at the bottom. Well, we don't have one. Characteristic 2 says the first non-zero entry coming in from the left is a positive 1. Yes. The leading 1 in the row above is farther to the left. Also true. And our fourth characteristic states that above and below all of our leading 1s must be all zeros. That is the case in this matrix. Therefore, it is in reduced row echelon form. Let's take a look at our last matrix. Characteristic 1 says if there's a zero row, it's at the bottom. Don't have one. Characteristic 2 says the first non-zero entry coming in from the left is a positive 1. Yep, those are our leading 1s. Characteristic 3 says the leading 1 in the row above is farther to the left. Also true. And characteristic 4 says every column containing a leading 1 has zeros both above and below those leading 1s. You'll see here in our fourth column, we do not have zeros above that leading 1. Therefore, this is not in reduced row echelon form. Now that we know how to identify a matrix in reduced row echelon form, let's talk about how to finish a problem once we have a matrix in reduced row echelon form. So consider this matrix we have in reduced row echelon form. We're going to write the corresponding equations, just like we did with row echelon form. We get x is equal to -2, y is equal to 1, and z is equal to 6. You'll notice that each of our equations contains just a single variable, and those variables are solved. Therefore, this technique does not require back substitution. We simply have our answer that needs to be written as an ordered triple, -2, 1, 6. So there's kind of pros and cons to whether you're going to use row echelon form or reduced row echelon form. It's a lot less work, a lot less row operations to get a matrix in row echelon form, but it requires more work at the end because you have to back substitute. With reduced row echelon form, it takes a lot more row operations, more work to get it into that reduced form. However, there's no back substitution at the end. Your answers are just given.